Hello, now we are going to start the logical objects of PostgreSQL database. So first logical object in PostgreSQL database, that is the table, and which is a very important logical objects of every database. And if we talk about the PostgreSQL database, so it is an important logical object in PostgreSQL database. So tables are the fundamental structure that store data in the tabular format, organized into the row and the columns. And in PostgreSQL database, we have many types of tables. So let's discuss each types of table one by one. First one is a regular table in which we store the data on the permanent basis, and which is the very simple command. We can create this table just like a create table and use the create table name and the column name and the data types. So we can create this table by the very simple command. This is a regular table. This is used for the store the data on the permanent basis. Second one is a temporary tables. So temporary tables are used to store data on a temporary basis and which will clear automatically at the end of transaction or end of your session. So we can use the temporary table for the some complex calculation. We can use the temporary tables in our procedures if we want to create a procedure, if we want to develop a logic, and let's suppose we want to create a balance sheet and we want to create a profit and loss. For that we have to perform some calculations. We have to perform some logics, and so for that we have to save the data in temporary basis. So we can use the temporary table for those types of the operation, and the regular table are those table which we can use for the permanently based saving of record, and the temporary table is used for the those record which we use for the temporary purpose. So as we know, in the PostgreSQL database we have lots of good options. So one of the good options in the PostgreSQL database is inheritance tables. Basically, it's allowed table or a child table to inherit column from one or more other table, just like a parent table. So this feature is useful for creating the complex schemas and can be leveraged to model hierarchical data structure or share the data structure among the related entities. And there are some key feature of inheritance in the Postgres database. This is the column inheritance. Child table inherit the columns from their parent tables. Additional columns can also be defined in the child table as well. And the queries on the parent tables can include data from the child table as well, depending on your query. Below is the example for creating the inheritance tables in Postgres SQL database. In the below example, we create a parent table. We have some columns of these tables. After that, we create a child table, and we use the clause in inherits uh, in the bracket the parent table name. So this is the command. By the use of this command, we can create the inheritance tables in Postgres SQL database. And if we perform this select on the parent table, so the child table record will also be retrieved in the select output. If we don't want to include the records, uh, so we can use the only statement. So we just use the select static only from the person. So it will not retrieve the record from the child tables. And we have lots of use cases for the inheritance tables. Let's discuss some useful use cases. For that, we can use the inheritance to model hierarchical data structures such as organization chart product categories, and taxonomies, and use of inheritance to reduce the schema redundancy by sharing the column and the constraint across the multiple tables. So, inheritance can help design more flexible and efficient database schemas. Second one is unlock table. As we know, the structure of PostgreSQL database. So, whenever we perform some changes, so changes first write to the wall files, then after that these changes write to in our permanent data files. So if we don't want to use this mechanism, so we can create a unlock table. For these unlock tables, PostgreSQL skip this mechanism. It will not create the wall records. It will not write the record of these table in the wall files. So we will get the better performance by the use of this unlock table. So we can use this unlock table for the record if we want to perform the bulk operation, if we want to perform some temporary calculations. So we can use the unlock tables feature for these types of the tables. But data is not crash safe, and it will be lost even of database crash. So one of the more powerful option for the PostgreSQL database, that is the partition table. Okay, so with designed to manage and optimize large data set for splitting a table into the smaller, more manageable pieces called the partition. This can significantly improve the performance and maintainability, especially for the large tables that handle the extensive data. And we have some key feature of partition table. This will improve the query performance. Definitely it will improve the query performance by scanning only relevant partition, so query performance can be significantly enhanced. Scalability, better scalability for the large data set, as the operation on the small partition are more manageable. And the, this is a very good thing for the partition table. This is a maintenance operation, and we can perform the vacuuming, indexing, and other maintenance operation can be performed more efficiently on a smaller partition. We have some types of the partition. First one is the range partition. Data is partition based on the range of values. List partitions, data is partition based on the list of values. The hash partition, data is partition is based on the hash function. And the composite partition, combining multiple partition methods. And the data archiving are more easy by the use of partition. The partition can add and drop as needed, manage data life cycle. So if we conclude that the partition tables in the PostgreSQL provide a powerful mechanism to handle the large data set efficiently. Now here we have some more logical object of the PostgreSQL database. First one is schema, which is a logical namespace within our database that helps organize and group the database objects. Database object like the tables, schema also contain the other kind of names objects, including the data types, functions, and the operators. And the same object's name can be used in the different schema without conflict. For example, so both schema 1 and schema A can contain the table name my table. And there are several reasons why one might want to use the schemas. So first one, to allow many users to use one database without interfering with each other. And the second one is to organize the database object in the logical groups to make them more manageable. And we can create a schema by the command create schema and put the schema name. And we can create a table just like a create table, and the schema name and dot my table. First we have to use the schema name and dot, and after that we have to use the table name. So we can use this syntax for creating the table in particular schema. And we can drop a schema. If you want to drop some schema, we can use the drop schema and schema name and the cascade command. It will delete all objects include in the schema. And we also have a public schema in PostgreSQL database. If we don't use the schema name when we create tables, so PostgreSQL database automatically put the schema name public before the table. Uh, so this table will be created as a public. Just like we can create a table, create table products. So to PostgreSQL database automatically create a table is public dot product. And second one is very common. The views. Views are the virtual table that represent the result of a predefined query. Uh, they provide a way to encapsulate the complex SQL queries and present them as a single and virtual table. And if we have let's suppose 10 column in our table, so if we don't want to show the all column of our table to the users, so we can create a tables for only for the 5 columns. So we can use the table for this type of the operation as well. Now let's discuss the very important logical object of Postgres SQL database, that is the indexes. So indexes are the database objects used to speed up the data retrieval by providing the efficient access path to the table data. And in the Postgres SQL support the many indexes type, and we will discuss each indexes type one by one. So first discuss the BT index. So a BT index in the Postgres SQL is a commonly used index type that support the efficient data retrieval and is suitable for the wide range of queries. BT index are a default index type in the Postgres SQL, offering the balanced performance for equality and the range query on the order data. And some of the key feature of balanced BT index is the balanced tree structure. BT index maintain a balanced tree structure. Second one is order data. So BT index store data in the sorted order, making them the efficient to range queries and order scan. And we can create a BT index by the very simple command just like create index name, and on keyword use, and after that we have to use the table name, and in bracket we have to use the column name in which we want to create a index. So BT index are the fundamental feature in Postgres SQL, which providing the efficient data retrieval for the wide range of the query. So after that, by understanding how to create and use and maintain BT index, you can optimize the performance of your Postgres SQL database, ensure the efficient data access by your application. And the second one, logical object and an index type. This is the hash index, which store key in the hash table and enabling the fast lookup for the equality searches. Okay. So, however, they do not support the range queries and ordered retrieval of data. Hash index are suitable for the extract match queries or on the columns with the uniform distribution of the values. And there are some key feature of hash index is first one is the equality queries. Hash index are optimized for the equality comparison, and the performance, and for it can be faster than the B2 index for the equality searches on the large data set. And it's a simple structure, uses a hash table to map index values to their corresponding rows. And we can create a hash table by the use of very simple command. We just create a create index and index name on the table, and using the hash, and then use the column name. And the hash table need to be re-indexed periodically to maintain the performance on the in the queries. And suppose that if we want to create a table of the which we have the email addresses of our users, and we using the equality comparison for searching the email addresses. So we can use the hash index for the use of for the emails on this table. So hash index can be beneficial in this scenario. So let's suppose we have a table. Let's like a we create a table, create table users, and we have the username, email, and created that. Okay, and then we create an index on the and some create index and index name on the users using hash and the email. Okay, so if you want to search, just like in select static from the users, and where email equals to and put the email address, so we will get the more performance if we use the hash index in this scenario. So hash index in PostgreSQL provide an efficient way to handle the equality queries and potentially offering the better performance than the v2 index for such use cases. So as we know, in PostgreSQL database, we have versatile and flexible index type that can be support various data type. So this index GIST generalized search tree is particularly used for the data type that do not fit into the traditional BT index structure. So this index are used for wide range of application, including just like geometrical data types, full text search, network address type, and the range types. Okay, so they support the advanced search operations such as containment and full text search. And GIN index are suitable for the query uh, involving complex data types and the search operations. And we can create this index by the very simple command, just like create index name on a table using GIN, and we can use a column inside a bracket. So this index is designed for allowing developer to create a custom data type and define indexing strategy for them. And the size of this index can be larger than the B-tree index because they store more information about the data structure. And the insertion process as compared to the B-tree index is might be slow because is due to the complexity of maintaining the balanced tree structure. And as far as about the query performance, this index can significantly improve the query performance for supported data type, particularly for the full text search. And we have to perform the maintenance operation like the vacuum and re-indexes on these types of index to get the optimal performance as well. To handle the very large table, PostgreSQL provide the one of best index type that is block range index, which organize data into the ranges of block offset and making them suitable for very large table with sorted or clustered data. They are space efficient and effective for the range queries on a large table with the sorted or the cluster data. And it's particularly useful for the column where the data has some natural order or is correlated with the physical order of the table. They are much smaller than the traditional index and are the particularly suited for the large table where a traditional BT index would be impractical due to its size and maintenance. And because of store the summarize rather than the detailed data, these index are much smaller and require less maintenance activity. And we can create this index by the very simple command, just like create index name on the table and using brin clause and put the column name within the brackets. And creation of this index is usually further faster the creation of the bt index because uh, is contain the less detailed information, and we have to perform the vacuum operation to maintain their efficiency and especially after the large data modification. But as compared to the traditional bt index, it requires a less maintenance. And we have some use cases uh, for the log table. For the log table where the entries are added in the chronological order, a index on the timestamp column can be very efficient. And for the sensor data and for the archival data. For the archival data type where records are inserted in the batches and have a natural ordering. The BT, BRIN index can improve the query performance for this. And this is one of the best index type in PostgreSQL database, uh, which created on this subset of rows in the table based on the condition. They are useful for indexing a specific subset of data and reducing the index size and definitely improve the query performance, and it is useful for the full table scan. We have many use cases. Let's discuss some major use cases. Like we can create the index on the non value. We can create the index on the active records. We can create index on the specific range. We can create the index on the Boolean flags. So partial index can significantly speed up the queries that filter on the index condition because index is smaller and more focused on the relevant rows. Uh, and we can create the index by the very simple command. Use the create index name on the table and the column. After that, we have to define a where condition. So, by the use of partial indexes, strategically you can improve your PostgreSQL database for specific query patterns, improving the performance and reducing the unnecessary storage overhead. And we can monitor the index by the view pg underscore stat underscore user underscore indexes. Use this system catalog view to monitor the usage of your partial index and access their effectiveness. And the partial index consume the less disk space compared to the full table index, but they still require the maintenance via vacuum and the analyze command. And you have to ensure that the condition in your uh, partial index is aligned with your query pattern. If your data changes or your query evolve, you may need to drop and recreate the index.